Question part 8. Let's talk about a ship. Before we do that, let's make sure we know our cardinal directions. So north is straight up, okay? East, south, west, all right? And so this ship intends to leave port. And I'm going to draw the diagram. So here's the ship. Intends to leave port at a perfectly northern course, but that's not what happens. This course, he actually takes an incorrect course. And he's 7 degrees off course. So let's draw in two things here. First of all, let's draw in his intended course because it gives us that. Oh man, that got out of control. So this is 1,000 feet, okay, or 1,000 miles, excuse me. But that's not what's going on. He actually kind of veers off course. I'm going to exaggerate it until he gets to a certain point. And he realizes a couple things. Number one, he's 7 degrees off of his intended course. And number two, he's 400 miles, he's traveled 400 miles at this wrong course. And so we know this distance has to be 400 because that's as far as he actually traveled. He corrects his arrow and steers back to his destination. How far is he from his destination? And so we have to do some calculation here, but first let's do some visualization. We need probably some triangles to help us out. So if I kick this one straight back, that should be a right angle. Now he's saying I do need to steer back to destination, which means he does this. So he immediately corrects his error, and he's like, oh man, I need to go here. So I actually need to find x. So to find x, to have a hope of finding x, I'm going to need some angles. Okay, which I do have one, which is 7. What I'm going to actually need now is just to do some solving, or at least make a solving to a plan. So it seems to me I can probably solve this triangle, and maybe even get this distance right here, which I'm going to call x. If I get x, let's try what color. Let's try it again. Okay, so I think I can solve this purple triangle, and I can find this distance x. All right. Now, I can also, at the same time, get this distance y. Now, the reason that's important is if I'm interested in the red one. I don't have any angles for the red triangle, so I can't use trig. But what I think I can use is a Pythagorean theorem. So if I'm able to find this distance y and this distance x, I should be able to subtract from 1,000 to get this part of the journey. So it's going to be 1,000 minus x. If I have the green distance and I have y, I should be able to solve using Pythagorean theorem for my red distance. I realize I've just doubled up a variable, so let's get rid of that. Actually, let's get rid of this one. Okay. And I'm going to call this one d for distance. So it seems to me the plan is to solve this triangle for x and y. That should give me enough numbers in the top triangle to solve this guy by Pythagorean theorem. All right, let's do it. So let's go to our bottom triangle. We got to solve for x and y. I'm going to solve for x first. Okay. So reference triangle is equal to the actual triangle. I need a reference angle. The only one I've been given is 7, so that's what I'm going to use. I need to find x. So to 7, x is adjacent. 400 is hypotenuse. So I need adjacent over hypotenuse for a 7-degree angle. And since they're similar, this truth should hold. In the triangle I'm solving, that will end up being x over 400. Going to my trig sheet. Go to my trig sheet. I need a over h. For a over h, the second column, it's for 7 degrees, so 0.9925. Okay. Now in terms of solving, I'm just going to multiply both sides by 400. Okay, which will leave x to be 397 miles. That's weird. That's exact. I'll be right back. I need to plug in my laptop. Alright, sorry about that, guys. My laptop is about to die. So anyway, that's X is 397 miles. Let's go ahead and solve for Y as well. Again, I'm going to use reference triangle, comparing that to my actual triangle. Now we have to pick a ratio as well. Y is the opposite to the 400 hypotenuse, so I'm going to rock opposite over hypotenuse for a 7-degree angle, opposite over hypotenuse for a 7-degree angle here as well. Boom, boom. Okay, so my actual triangle, that'll give me Y over 400. Let's go to our trig sheet. I need O over H for 7. Over H is my first column, 7 is here, so I need 0.1219. Again, simple algebra here. Multiply both sides by 400. It'll cancel just like it did there. So Y in this case should be 0.1219. Okay, so Y should be 48.76. So if you look at the diagram, so what that means is that distance here, the distance here along the pink line is 397 miles, which is what he should have done, but he actually figured 400 in the wrong direction, which means he's 48.76 miles off course. So I'm going to transfer some of these numbers. So this is 48.76. And this number here is 397. Okay, so with that information, we can kind of start filling in some of the upper triangle. So if the entire journey was 1,000 miles and he should have gone 397, so this linear distance he's left to travel is 100 minus that, or 1,000 minus that. So we take 1,000, subtract off 397. That leaves 603 miles along our original course. So this distance is 603. Well, I know it's a right triangle. If that's 603, I know it's 48.76 along the bottom. I should be able to solve for the distance he still needs to travel by using the Pythagorean theorem. So d squared is equal to 603 squared. Okay, plus 48.76 squared. And so that's a matter of solving. So 603 squared. 48.76 squared is 2377.5376. Let's add that together. Okay, and then take the square root. So the distance this captain's left to travel is 604.9682 miles. Okay. Oh, man. Yep, I did it again. Oh, geez. Alright, so let me kind of quickly review stuff you'd missed. Oh, man, that's like the third time I did that. So I pulled the value off the trig sheet here, and then I just went about solving for y, so that's 48.76. So the conversation I was having is that if you kind of transfer those to your triangle, you can kind of connect this back to the situation. So The x being 397 means if he did do the right thing, he should have been 397 miles into his journey. He didn't do the right thing, which means he was off because he traveled about 3 extra miles. Now, overall, this 48.76 means he's 48.76 miles off his intended course. Because when he realized his error, he was here but should have been here. So if it kind of transfers to now the triangle he has to finish traveling, if I want to know the red distance, I can just use actually Pythagorean theorem because I know I'm 48.76 miles off my course. This green number is going to be 1,000 minus 397. So if he had done the right thing, he'd only be 603 miles from his destination. But then using the Pythagorean theorem, which of course you know is c squared equals a squared plus b squared. I can use 603 and 48.76 to actually fill in those numbers, which I did, which means this d distance, the red distance that I have left to travel, is just a paltry 604.9682 miles. So a little bit farther than normal. He didn't veer off that much off course, but he caught his error early. There you go. And so I'm sorry I left that trig sheet in front of the problems like 3 times. But there you go. There's the entire problem. Not, yeah, not the easiest test in the world, guys, but one that's 100% doable if you're willing to put in the work. So think about like Spartan time over the next couple of days. Certainly have this key to help you too. That's it, guys. That's part 8, I think. So there you go.